Mathematical logic. We will define a statement. A statement is a collection of symbols which is meaningful in the sense that is either true, denoted by T, or false, denoted by F. But it can't be both. Now that we have defined a statement, we will define a compound statement. A compound statement is a statement formed by joining two or more statements. This is called a compound statement. We can join two statements by using a conjunction. So the first one is conjunction of two statements. Let's say if P and Q are two statements, then we can form a single statement by joining them with the word and, which is symbolized by this symbol. Hence, the two statements joined can be written as P and Q. This is read as AND. Now we need to know that P and Q is true only when both P and Q are true. We can write this using a tabular form, which is known as the truth table. For this truth table, we will make 3 columns. The first column is P, the second one is Q, and the third one is P and Q. So we will write the possible conclusions. First, in the first case, both P and Q can be true. In the second case, P can be true and Q can be false. Similarly, in the third case, P can be false and Q can be true. And in the fourth case, both P and Q can be false. So these are the four cases. Now we know that when P and Q is true, it can only be true when both P and Q are true. Then for only the first case, P and Q is true. For the rest of them, it is false. The second one is for disjunction of two statements. Here also we will take P and Q, two statements, which we can form a single statement by joining them with the word or, which is symbolized by this symbol. Hence, P or Q, this is read as or. Then P or Q is true when at least one of P and Q is true. So like we made a truth table for and, we will make a truth table for or. We will give the heading just like the previous table, which is PQ and P or Q. Here also there will be four cases: true, 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 false, false, true, and false, false. As we know, P or Q is true when at least one of P and Q is true. Then in the first case, both of them are true. That means P or Q is true. In the second case, P is true, which means P or Q is true. In the third case, Q is true, then also P or Q must be true. But for the fourth case, that is both of them are false, then P or Q will be false. After this, we will learn negation of a statement P. The statement obtained by prefixing a not with the statement P is called negation of P. Now this is denoted by this symbol. This is read as not P. For this too, there is a truth table. In this truth table, there will be two columns. First one is P, second one is not P. Here there are two cases, true and false. For true, when P is true, then not P will be false, and when P is false, not P will be true. Then we have conditional statement. implications between two statements P and Q. Now this is written as P implies Q. We read this as P implies Q, where P is the hypothesis and Q is the conclusion. Now this also stands for P only if Q. Also P is sufficient for Q and Q is necessary for P. So P implies Q is always true except in the case when P is true and Q is false. So we will make a truth table. In this truth table, we will make 3 columns: P, Q and P implies Q. So there are 4 cases: true, 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 false, false, true and false, false. We know that P implies Q is always true except in the case when P is true and Q is false. So when P is true and Q is false, that means the second case. For the second case, P implies Q will be false, and for rest of them it will be true. This brings us to biconditional statement. When P implies Q and the converse, which is Q implies P, are both true, we may write P implies and implied by Q. So this symbol is read as implies and implied by. This also stands for P if and only if Q. This is read as if and only if. Now we will draw up a truth table for biconditional statement. In a similar way, we will make the truth table with 3 columns: P, Q and P implies and implied by Q. Here also there are 4 cases: true, 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 false, false, true and false, false. For the first case, we will have true. For the second case, false. Third case, false, and the fourth case is true. Because true implies and implied by true and false implies and implied by false. So only these 2 statements will be true. Let's look at an example. We need to draw a truth table for P and Q or not R. Here P, Q and R are three statements. So the truth table is as follows. This truth table has 6 columns. The first 3 are reserved for P, Q and R. The fourth one is for not R. Fifth one is for P and Q. And the sixth one is for our given question, which is P and Q or not R. So first we will write all the possible outcomes under P, Q and R. The first case is when 3 of them are true. Then when one of them is false, then true, true, false, true, false, true, false, true, true. When 2 of them are false, then we will have true, false, 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 true, false, and false, false, true. And the last case is for when 3 of them are false. False, false, false. Then we will fill up the fourth column, which is not R. So this will correspond with the column R. For true we will write false, and for false we will write true. In this way we fill up the column. The next column is for P and Q. So for this one we need to look at the first 2 columns. True, true gives us true. True, false gives us false. False, true gives us false. True, false, false. False, true, false. False, false, false. And false, false, false. So the last column, for that we need to look at not R and P and Q. So this or this, which means true or false, gives us true. True or true gives us true. False or false gives us false. In this way we will fill up the column. In a similar way, if we are given this example, where we need to prove that not P and Q is equal to not P or not Q. So we will draw up a truth table. Okay, so let's fill up the columns. The first 2 are for P and Q. The third one is P and Q. The fourth one is for not P and Q. We will fill these 3 later. So here there are 4 cases: true, 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 false, false, true, and false, false. Then P and Q must be true for the first case and false for the rest of them. Using the third column, we will fill up the fourth one, which is not P and Q. This is false and the rest are true. So we have got the left hand side, which is not P and Q. For the right hand side, we will write not P, not Q, and this one, which is not P or not Q. So for the fifth column, we will use the first column. From that we can write false, false, true, true. Similarly, the sixth column will be filled up by using the second column. So this will be false, true, false, true. And using the fifth and sixth column, we will fill up the seventh one, which is not P or not Q. So false or false gives us false. False or true gives us true. True or false gives us true. And true or true gives us true. So in this way, the truth table is formed.